Welcome to Mathematics Online Lecture Series, lecture number 18, Change of Order of Integration in Double Integrals by Professor K.V. Narsum, Department of Mathematics, Indian Institute of Engineering and Technology, Vijayanagaram. Today we will discuss very interesting problem based on change of order of integration. So a little bit different problem. Now look into the problem. Evaluate the integral by changing the order of integration. Integral 0 to 1, integral x square to 2 minus x, xy dx dy. Now, this integral in terms of x variables, now it is y. Now, other variable is x. So, the given integral is integral 0 to 1, integral 0 to 1, integral y equals to x square to 2 minus x, xy dx dy. So if you observe this integral, the region of integration is given by y equals to x square, lower limit, upper limit is y equals to 2 minus x, it is a straight line, and x equals to 0 to 1. Now it is, now this is the double integral. First we will integrate with respect to y, then integrate with respect to x. First we will find the region of integration. So for applying this method, first find out the region. First step, region, find out the region. Okay. Now in second step, change the order of integration with the limits. Now third step, evaluation. Now observe. Now if you observe this problem, y limits x square to 2 minus x. Y equals to x square, it represents a parabola. Okay, fine. Y equals to 2 minus x is nothing but x plus y equals to 2. Suppose if you divide with 2, what happened? This is x by a plus y by b equals to 1 form. So x-intercept 2, y-intercept 2. So this is a straight line. Straight line. Here x-intercept is 2, 2 comma 0 here. Here 0 comma 2. Now this is another point of intersection. Here this is point. Now what is the point of intersection of this straight line and this straight line and this one? Okay, we will discuss. We will find the point of intersection of these two, then you will get this point. Already this point is known. This point is also known. Okay. Now what? Now point of intersection. Just very simple method. Here y equals to x square, y equals to 2 minus x. Now y equals to x square, y equals to 2 minus x. Now equating left hand sides are equal, right hand sides are equal. Then x square equals to 2 minus x. If it goes to left hand side, x square plus x minus 2 equals to 0. So if you find the roots of the quadratic equation, x equals to 1 and minus 1. Now if you substitute the x value in any one of the equation, you will get y equals to 1 and 4. Now corresponding points, x equals when x equals to 1, y equals to 1, x equals to minus 2, y equals to 4. So first point of intersection is 1, 1, other point of intersection is minus 2, comma 4. So this point of intersection is 1, comma 1. Now another point of intersection is if you extend this line and parabola, you will get another point of intersection, a dash. So that one is not required. So in this problem, lower curve is parabola to straight line. Parabola to straight line. Now I am drawing the arrow marks. Parabola to straight line. Now x value here 0, 0. X is 0 to 1. Lower limit is x, upper limit is 1. So this is the region. X equals to 0 here, while x equals to 1 here. So this region is our region, which is shown in our diagram. Now clearly, which is mentioned here. So this is the straight line x plus y equals to 2. This is parabola y equals to x square. Point of intersection is 1, comma 1. A y-intercept is 0, comma 2. Here another intercept, that one is not required. This is origin. Okay, fine. Now this is the origin. This is the total region. So according to the given problem, we are identified the region. This region is our region. Okay. Now change of order of integration. Now change of order of integration in the previous problem, integrating with respect to y, then integrate with respect to x. The given problem is this one. Now change the order of integration. Now change the order of integration. So first integrate with respect to x, then integrate with respect to y. So now if you want to find the limits with respect to x, observe along the x-axis. Along x-axis. Now if you observe, I will take another color. Take red color, green color. Now this one. If you observe along x-axis, the curve is here straight line, then parabola. Two types of curves are there along x-axis. From along x-axis, starting point is at x equals to 0 to. So we have two different curves. One is first curve is this one. Now second curve is different curve. In the previous problems, different problems curves are same, but here two different curves. For this purpose, divide the total region into two parts. This is circular, this is straight line part, this is parabolic part. Now divide into two parts. First upper part is R1, second upper part is R2. I will show you in the diagram. Now same diagram. So here up to this straight line, here parabola. So divide into two regions. Now we will now the total integral R equal double integral is nothing but double integral over R1 plus double integral over R2. So now the total region is divided into two regions over R1 and R2. So for R1 region, what about the x limits? First x limits along x-axis. Here, observe this one. Here starting is x equals to 0 to. Now this curve is x equals to, now from this one x equals to 2 minus 1. 2 minus 5. 2 minus 1. Now y limits, very simple. Here starting y coordinate is 1, 1 to 2. Here 1 to 2. 1 to 2. So for upper region, the limits are x equals to 0 to 2 minus y and y limits 1 to 2. Now for lower region R2, what about the x limits? Along x-axis, now observe here this is x equals to 0 to. Okay, fine. Now this is parabolic curve. From this one x equals to root y. So root y. Now y limits. In this region, R2 region, here y coordinate is 0, here y coordinate is 1. So y limits 0 to 1. Very simple. This is most important problem. That's why this is most important problem. Why? So the total region is divided into two different regions, R1 and R2. Now separately find the integrals for R1 and also R2. Now this is most important one. For R2 region, the limits are x equals 0 to root y and y equals to 0 to 1. Now we will evaluate the integral. So first step is the identification of region, then change of order of integration, finding the limits for change of order of integration, then change of the order of integration. Now this is the given problem. X is 0 to 1, y equals to x square 2 minus x xy dy dx. Now this is divided into two regions for R1 region and also R2 region. For R1 region, limits already discussed 0 to 2 minus y and y limits 1 to 2, already clearly mentioned here. 0 to 2 minus y equals to 1 to 2. And for the upper region, for the lower region, x equals to 0 to root y. Here 0 to root y. Now y equals to 0 to 1. Integrand is same, xy dx dy. So first integrate with respect to x, then integrate with respect to both the integrals. So for this purpose, separate the x variables and y variables. Now inside x variables, here also in the second integral x variables. Now integral x equals to non-x integral x dx equals to x square by 2. Known formula x square by 2. So x square by 2 here also same integral x square by 2. Here limits are different. X is 0 to 2 minus y. Here x is 0 to root y. Now here put y x equals to 2 minus y here, and then minus x equals to 0. Okay, this is for first integral. Now for second integral, put x equals to root y, then x equals to 0. Okay, the remaining part is same. Y is 1 to 2, here y is 0 to 1. Now simplification, here 1 by 2, 1 by 2 is the common term, integral 1 to 2, 2 minus y whole square is nothing but 4 plus y square minus 4y into y dy plus y into root y whole square is nothing but y, and here into y, so y square. Now again multiplying with y, so integral 1 by 2, integral 1 to 2, 4 into y plus y square into y cube minus 4y into y square plus 1 by 2 into integral 0 to 1 y square dy. Now 4y integral 4y is 4y square by 2, integral y cube is y power 4 by 4, y square is y cube by 3, here y square is y cube by 3, here limits 1 to 2, here 0 to 1. Now first put y equals to 2, 2, 2 in this 3 times. Then put x equals to 1. Here 1, here 1, here 1. You will get this term. Plus 1 by 2 times. So if you put y equals to 1, 1. If you put y equals to 0, this is 0. Now it's very simple simplification. Very simple methodology. Here 2 to cancel. Here 4 cancel, and simplification is very simple. 8 plus 4 minus 32 by 3, here my 2 plus 14 minus 4 by 3 plus here 1 by 6. If you simplify entirely, you will get 3 by 8. It is very simple calculation, 3 by 8. Now this is very easy and most important question. So evaluate the double integral. Evaluate the double integral. Integral 0 to 1 integral x squared to 2 minus x xy dx dy. Now this is the different problem and most important one. So now we will discuss another problem, problem number 10, but both are look like similar problems. But in the previous problem, integral 0 to 1 integral x squared to 2 minus x. So integrand is different. Okay, limits region of in the integration is almost the same. If you put a equals to 1 in the second integral, you will get the first one. Okay, similar problem. Integral 0 to a in now in terms of x squared. So it is y, other variable is x. Y equals to x squared by a to 2a minus x equals to 0 to 1. This is look like our previous problem. Now region of integration is bounded by y equals to x squared by a, y equals to 2a minus x, and x equals to 0 and x equals to 1. Same procedure, same methodology. Y equals to x squared by a is also a parabola, and y equals to 2a minus x is also, sorry, parabola. Now this is if you common x plus y equals to 2a, same. In the previous problem a is 1, now different. Now 2a, y x-intercept is 2a comma 0, y-intercept is 0 comma 2a. In the similar way, equating y and y, you will get a y and y, so point of intersection, x square by a equals to 2a minus x. Now if you simplify, x square plus xa minus 2a whole square equals to 0. If you find the roots of the quadratic equation, a comma minus 2a. So in the previous problem, 1 comma minus 2, here a comma minus 2a. Now if you substitute x value in any one of the curve, you will get a comma 4a. So first point is a, other point is minus 2a comma a. Alright, this point is a comma a. Now another point of intersection is look like here. That one is not required a dash. So now in this integral, along y-axis, along where lower curve is parabola to straight line, then x is 0 to a, same region like our previous problem. same region, but points are different. So the curves are a little bit different. This is x square by a. Okay. Now same procedure for change of the order of integration. First we want x limits, then we find the y limits along x-axis. If you observe along x-axis, this is a straight line, then parabola. Straight line parabola. So for this purpose, divide into two different region, R1 and R2. I will show you in this. This is x. Upper region is R1 and lower region is R2. Now for upper region along x-axis. Now first one is y x equals to 0 to straight line equation from this one. From this one x equals to 2a minus 1. 2a minus 1. So it is clearly mentioned here 2a minus 1. Y limits here y equals to a to 2a. So a to 2a. Now for the lower limit, same procedure like our previous problem. So along x-axis, so starting is x equals to 0 and this one. So from this one, y equals to x square a, x square by a equals to x equals to root over ay. So root over ay. Now y limits here, y coordinate is 0, here y coordinate is a, so 0 to a. Like our previous problem, similar problem. If you put a equals to 1 in this problem, you will get the previous one. Now we will evaluate the integral. So same procedure, x is 0 to a, y equals to x square by a to 2a minus x. So divide into two regions. So first one is for R1, this is for R2, same integral. Now limits for lower limit x is for upper region x is 0 to 2a minus y. Already we discussed here. Uh, y limits a to 2a and y equals to 0 to a and x equals 0 to root over 2y, not 2y. Sorry, this is ay. This is ay. Root over ay. Typing mistake. Okay. Now separate the x variables and y variable. First we will integrate with respect to x, then integrate with respect to y. For this purpose, separate y variables outside. Now here only x integral already discussed. Integral x is x square by 2. Limits a x equals 0 to 2a minus y. Here same x square integration is x square by 2. X is 0 to root over ay. Now substitute x equals to 2a minus y first upper limit, then x equals to 0. You will get this one. Okay, in the similar way, put x equals to root over ay, then x equals to 0, you will get this one. Now 2a minus y whole square like our previous problem, 1 by 2 times of a, y is a to 2a, 4a square plus y square minus 4a by into y square dy. Here a by 2 is the common term, integral 0 to a, here y root over y square is y into y is y cube. So y cube. Now multiplying with y square, 4a y square, y power square to y square, y power 4, y to y square, y cube. Now this is the intake 1 by 2 times of integral a to a 4a square y square plus y power 4 minus 4a y cube dy plus a by 2 integral 0 to a y cube dy. Now y square integration is y cube by 3, y power 4 integration is y power 5 by 5, y cube integration is y power 4 by 4, y cube integration is y power 4 by 4. Now 1 by 2 times of 4a square y cube by 3 plus y power 5 by 5 minus 4a y power 4 by 4. So limits a to 2a and plus a by 2 y power 4 by 4 limits a to 0 to a. Now first put y equals to 2a in the each and every term, 2a in the each and every term, then substitute second limit a. Then finally in the second term a by 2, if you put y equals to a power 4 by 4. Now if you simplify 1 by 2 times of this is 32, 8 fours are 32, a power 5 by 3, 2 power 5 is nothing but 32, a power 5 by 5 minus 4 cancel, 2 power 4 is 16, a power 5 minus, here you also 4a power 5 by 3, here a power 5 minus 4 cancel, a power 5 plus a power 5 by 8. Here a power 5, here a power 5, a power 5, a power 5 is the common term, 1 by 2 is also common term. So you will get 32 by 3, 32 by 5 minus 16 minus 4 by 3 minus 1 by 5 plus 1 minus 1 minus plus 1, and if you come inside 1 by 4 into 1 by 2 1 by 8. So if you simplify, finding the LCM and the simplification, 47 by 160. So finally you will get 47 a power 5 by 120 is the answer. Now integral 0 to a y is x square by a to a minus x y square dx dy equals to 47 a power 5 by 120. In the previous problem, a equals to 1, but integrand is x into y. Here x into y square, different problems. Both are look like similar problems. So if you have any doubts, ask any doubts through my email ID and WhatsApp. Thank you. Thank you very much.